In this video, we solve the second numerical of metacentric height. So first we understand the problem statement. A block of wood of specific gravity 0.7 float in water, means one wooden block is given and it is float in a water, and the specific gravity of this wooden block is 0.7, and we need to determine the metacentric height of the block, and it is 2 meter into 1 meter into 0.8 meter, means the dimension of the wooden block is given 2 meter into 1 meter into 0.8 meters. Now here we see this is the water level, and on the water level this is the wooden block are there, and the wooden block height is 0.8 meter, and this is the 1 meters and its length is 2 meters. Now first we write down the given data. So first its dimension are given, that is 2 meter into 1 meter into 0.8 meter. Depth of immersion is equal to h meter. So in a last numericals, the depth of immersion is already given. But in this case, the depth of immersion is not given. So we can consider it is the h. And first we need to find out the depth of immersion. Then after we are able to find out the metacentric height. Third, specific gravity of wood is given, means here the directly density is not given. Specific gravity of the wood is given, it is 0.7. So in a first chapter we already study the definition of specific gravity. So what is specific gravity? So from the specific gravity we are able to find out the density or a weight density of a wooden block or wood. So specific gravity is also called as the relative density of a fluid, and it's defined as the ratio of weight density of fluids to the weight density of the standard fluids. So as a standard fluid we can consider it is the water, okay, and the fluid, so here we consider it is the specific gravity is equal to weight density of wooden block divided by weight density of standard fluids. So standard fluid is water, and water weight density is 1000. So 1000 into 0.7, so it is a 700. So what is 700? 700 is the weight density of the wooden block or a wood. And in these numericals we need to find out metacentric height, and it is denoted by gm. So what is the equation of the metacentric height? It is the moment of inertia I. So moment of inertia, so here the rectangular component are there. So moment of inertia equation is the b into d cube divided by 12. This is the body submerged in a water. Okay, so it is the one volume of the body submerged in a water. So we need to find out this volume, and this is the b to g, means distance between the buoyancy point and the g point. So when we are able to find out this buoyancy point, when we know this h, okay, so when first we need to calculate the h. After the h, calculation of the h, we are able to find out this b, and first we need to find out the g. So g is findable because it is a center of gravity. So height is 0.8 meters. So center of gravity means a to g is the 0.4 meters. Okay, so first we find out the h. So find out the h. First we need to find out the weight of the wooden piece and the water displaced by this wooden piece. So what is the weight? Weight is equal to weight density of the wood into the volume. Okay, so what is the weight density of the wood? So weight density means the first we need to find out the weight density of the wooden block. Okay, so what is weight density of the wooden block? It is specific gravity into density of the water that we already discussed in the last slides, into g, it is 9.81. and what is the volume? Volume is the 2 into 1 into 0.8. okay, so this is the value of the weight of the wooden piece. Now weight of the water displaced. So weight of the water displaced by it is the wooden body is equal to the weight density of water into volume of wood submerged in a water. So what is the weight density of the water? Weight density is the rho into g. So rho is the density of water, it is a 1000, and g is the gravitational force, that is the 9.81. Now volume of wood submerged in water. So volume is the it is 2 meter into 1 meter submerged inside the water, so this height is the h. So here we write down this h. Okay, and according to the our theory, these both are same. So weight of the wooden piece is equal to weight of the water displaced. So we equivalent these two values, then we are able to find out the h. So here 0.7 into 1000, it is written 700 into 9.81 into 2 into 1 into 0.8 is equal to weight of water displaced. So these values are mentioned same as it is 1000 into 9.81 into 2 into 1 into h. So here h is equal to 0.56 meters. So here we calculate the h. Now we are able to find out the b and also the metacentric height. So distance of center of buoyancy from the bottom means it is the distance a to b. So a to b is equal to h divided by 2. So h is the body submerged inside the water divided by 2. We can able to find out the a b. So 0.56 divided by 2 is equal to 0.28 meter. So this a to b is equal to 0.28 meters. Now we need to find out the metacentric height. So what is the equation of the metacentric? It is gm is equal to I divided by volume minus bg. So first we find out the bg. So what is the ag? So ag is the 0.8 divided by 2. Ag means center of gravity from the bottom. So it is a total height of the wooden block divided by 2. It is a 0.8 divided by 2.4 meters. And bg means distance between the buoyancy point and gravitational point is equal to ag minus ab. So last we find out the ab and here the ag. So ag is 0.4, ab is 0.28, so bg is the 0.12 meters. Now next we find out the moment of inertia I. So it is b into d cube divided by 12. So it is a 2 meter and the 1 meter, so 1 cubes. So b, that is a 2 into 1 cube divided by 12. So 1 cube is 1. So answer is the 1 divided by 6 meter raised to 4. Next we need to find out volume of wood in a water. So it is a this 2 meter into 1 meter into this h. What is the h? H is the 0.56. So we multiply 2 into 1 into 0.56. We get the answer 1.12 meter cubes. Now we put all these three values in the equation of the metacentric height. First we put this value of I. It is 1 by 6 into this volume of wood in water. It is a 1 divided by 1.12 minus bg. It is a 0.12. So we get this answer of metacentric height is 0.0288 meter. So here we solve our numerical. So thank you for watching this video. If you learned something, then like the video and subscribe my channels for watching the more video related to fluid mechanics and other subject of mechanical engineering. For FMHM, various link is provided in descriptions as well as in car. For other subject, I request to visit the playlist and don't forget to share with your friends.